Hi folks, we're going to take a look at number 12 from page 333. So they give us this equation, so it means this equation is true, and they give us information about these vectors x, y, and z that appear in that equation, except the vectors have variables in them, okay? And they want us to determine what values of a, b, and c are going to make this equation true. Okay, so the first thing I'm going to do is go from this vector notation form to using this component notation. Okay, so I'm going to show every step here. Certainly, some steps you can skip. So here I'm going to actually write out 2 times the vector. If you were to just multiply out the 2 right off the bat, that'll be perfectly acceptable. So here I've got 2 times x, so negative 1b c. Okay, plus y, which is just a negative 2c, and then minus 2z, so 2 times negative a 6c, okay, and that's equal to the 0 vector. Now, because I'm writing everything in component form, I'm going to write the 0 vector in component form, so 0, 0, 0. Okay, so now the trick here is to just simplify both sides and then equate the different components. Okay, so here what do we have? We have in the x, we've got negative 2, okay, plus a, okay, and then negative 2 times negative a is going to be plus 2a. Okay, in the y component, we've got 2b. Okay, so here I'm skipping a few steps. Okay, minus 2, and then minus 2 times 6, so minus 12. Okay, and then in the z component, we've got 2c. Okay, plus c. Okay, and here minus 2c. Okay, and all that is equal to 0, 0, 0. Okay, so now that I've got 2 vectors that are equal to each other, I know that the x, y, and z components must be equal to each other. So here, let's start with x. We have negative 2 plus a plus 2a has to be equal to that x component, which of course is just 0. So we have negative 2 plus 3a equals 0, 3a equals 2, a equals 2/3. Okay. So there's our first unknown. Okay, now let's work with the 2 y components being equal. So we've got 2b, negative 2 minus 12 is minus 14 equals 0. So 2b equals 14. B is equal to 7. There's our second component. And lastly, we've got the z's. So here we've got 2c plus c minus 2c out. The 2 c's just cancel out. I'm just left with c equals 0. And so there you have it. No work to be done. Okay, so just a quick recap here. Step 1 was to take this equation given in vector notation and rewrite it in component notation so that you can more easily add and multiply the vectors as needed. Once you have 2 equal vectors, you then just equate the x components, the y components, and the z components. Okay, that's it for this one.